Hello everyone, welcome to InfoStream YouTube channel. So in this video, let's discuss how to solve the Turing machine problem easily. So if you see here, they have given a language. So first, let's draw the strings. Let's draw the possible strings from the given language. So here, a power n, b power n is the given language, and they have set the condition that the n value must be greater than or equal to 1. So now, when I put n value as equal to 1, because the least condition is greater than or equal to 1. So when I put n value as 1, a power 1 and b power 1, that is a 1 time, b 1 time. Next, when I increase the value of n from 1 to 2, so it will be a power 2, b power 2, that is a will be written 2 times, b will be written 2 times. Next, if we move for 3, so n value is 3, a 3 times, b 3 times. So like this only it will continue up to the n number of elements. Now which string we should take to design the Turing machine? Whether I must take 2a 2b or 3a 3b, this confusion will come to all the students. So the shortest trick is, how many number of variables are there? A is the one, b is the second. So 2 variables. So what you must take? A power 2, b power 2. A power 2, b power 2. This string will be selected. If it was A, B, C, then what you will be doing? A power 3, b power 3, c power 3. This string will be selected to design the Turing machine. Now here we are having 2 variables. So A power n, b power n means A power 2 and b power 2 string will be used to design the Turing machine for this language. So now we got the string. So in this string 2a, 2b. So these are the string elements, and here what will happen is, in the front side, that is in the front side and back side, both the side, because we are choosing a specific string in the infinite string. Specific string in infinite string. So what will happen? Blank spaces will be there in front of it, and blank spaces will be there in back side also. So now if you see, back side also blank spaces. This is the specific string we selected, 2a 2b and 2 times a and 2 times b. Next, blank spaces will continue as it is when the string is over. Now we must start from a. So this arrow which I am showing will be called as the read write head. Read write head. So the speciality of this read write head is, it can move right side, it can move left side, and it has the capacity to change the value or rename it. So now if you consider only for the right hand side, that is the blank spaces which are behind a, which is the starting element of the string we selected, so will be not be considered to design the Turing machine. Only the elements after the starting element a will be considered. These blank spaces will also be considered. These blank spaces which are behind the specific string we selected will not be considered for designing Turing machine. So now we are starting from a. My read write head is at a. So let me start from the q0 state. So this is the initial state. You can use any variable to show the states. So now a. So what I will be doing, when I will be approaching a one time, approaching the a for the first time, I will replace its name as x. So what I will be doing, when I approach a, I will rename it as x and move towards the right side. When I approach a, I will rename it as x and I will move to the right side. So I will write it as q1. From q0 I will be moving to q1. So now my read write head will move towards the right side because the command has been given to move to the right side. Now I again approached a. So here what I will be doing is, I will be giving the self loop, that is when I approach a again, I will write a as it is and move towards the right side. Why I wrote the self loop and wrote a as it is when I approached a for the second time is, how Turing machine work means, if it replaces a as x for one time means, it will move to b and rename it as y again. Then it will again come back to a and again it will move to b. Like this. One time a, one time b. One time a, one time b. Alternatively it will work. If it rename a for the first time, then it will move to b and then it will rename. Again it will come to A, again it will rename as X, again it will move to B, again it will rename as Y. Like that the process will continue. So what I did, until B will be appearing, it will be self loop at this state itself. When A will approach, it will rename it as A itself and move towards the right. So my arrow was here, that is rewrite it was here. When I give the command to move towards the right side, it will move to here. Now I approached B for the first time. One time A is over, next time B. One time A is over, so again what we must do, we must rename B for the first time as Y. So I will be moving from Q1 to Q2 state. When I approach B, I will rename it as Y and I will move towards left. Why I am moving towards the left means, I am having only two variables, A and B. One time I replaced A using X, another time I replaced B using Y. So what I will be doing, again I must come back to A. So what I did, I gave the command to come towards the left side. So now if you see here, I came here. So when you come here, you cannot rename it directly, because you must again move back to X and again come back to A. When you are renaming A for the second time, you must come to X, that is renamed A, and again you must move to A. So what I will be doing, I will be giving the self loop. When you approach A, write A as it is and move towards left. So when you came left side, you approached X. So when X will be coming, you write X as it is and move towards the right side. So when you move towards right side, again you will approach A. So you will replace A as X and move towards the right side. So when you move towards right side, you approached Y, because B has been replaced using Y. So what I will be doing, if you approach Y, write Y as it is and move towards the right until you get B for the second time. Two times we replaced A as X, but only one time we replaced B as Y. So for the second time I must move to B again. So now I came to B, because the command gave to move to the right. When I approach B, I will replace it as Y and move towards the left side. So when I came to left side, now B has been replaced as Y. So what I must be doing, Y right as it is and move towards the left side. So if I move towards the left side, I encountered A. When I move to the left side, I encountered X. So when X is there, write X as it is and move towards right. So again I came here. So here I am stuck in a loop, because all the string elements in the selected string for the given language is over. That is, we renamed them as X and Y. So what I will be doing, now I just want to represent the blank spaces. So what I will be doing, I will be taking a separate one from the Q0 state. Because if you see here, when you approached X, you replaced X as it is and told to move towards the right. At present I am in Q0 state itself. So I am starting from Q0 itself. Q2 is over, I will be writing Q3 state. So what I will be writing is, so now I want to travel to B. At present I am in Y. So what I will be doing, when you approach Y, write Y as it is and move towards right side. Next, again if I move towards right side, if you see, again I encountered Y. So I will be giving self loop. How many Y will come, you will represent Y as it is and you will move towards the right side. So now I approached the blank space. So what I will be doing, when you approach the blank space, write it as blank space and move towards the right side. So again I am moving to the right side, that is blank space. So infinite number of blank spaces can be there. So what I will be doing, I will be writing Q4 as the final state, which I will enclose it using the 2 circle and I will give the self loop. That is, how many times B will occur, write it as B and move towards the right until you encounter the last B and represent it using this Q4 state. So you can write this self loop state, or you don't need to write it, because when you approach B, you will be moving to the final state. That is, when you approach the blank spaces, you will be moving to the final state itself. So no need to represent it, or you can leave it as it is. Now let's write the transitions. So transitions, how we will write? Do of. Now I am moving from starting, you must write Q0 to Q1. I am moving from Q0 to Q1. So from Q0 to Q1 means when I give A as the input, it replaced A as X and moved towards right side. A as X and moved towards the right side. Like this you must write. So just put comma here. Next, another one from Q1 to Q1 itself, self loop. Two states you must represent. Do of Q1 to Q1 itself. When you give A as the input, it replaced A as it is and moved towards the right side. Another one is do of Q1 and the state is also Q1 because self loop. When you give Y as input, it replaced it as Y and moved towards the right side. Next, from Q1 to Q2, do of Q1 to Q2 state. So what it did? B, when you give B as the input, it replaced it as Y and moved towards left side. B, it replaced it as Y and moved towards the left side. Next, Q2 state. Two states are there, self loop. So do of Q2 comma, when you give Y as the input, it replaced it as Y itself and moved towards the left side. Next, another one. Do of Q2 comma, when you give A as the input, it replaced A as it is and moved towards the left side. Next, when you give X as the input, it replaced it as X and moved towards the right side from Q2 to Q1. So do of Q2 comma X will be equal to Q0 comma X comma right side. Next, three states I will write here. Do of, when you give Y as the input, it replaced it as Y and moved towards the right side from Q0 state. So it will be equal to, for Q3 it went, it replaced it as Y and moved towards the right side. Next, do of Q3 self loop. So Q3 comma Y will be equal to Q3 comma Y comma R. Next, B, that is for blank space. Q3 it went to Q4. So blank space means, so blank space itself and move towards the right side. So this like you must write. For this one also you can write, or you don't need to write it again because the same state will be there. So hope you understood how to solve the Turing machines problem. If you have any doubt regarding this topic, please do comment below, and the more video links are given in description through the playlist. You can access it, and if you solve all the problems related to Turing machines which I provided in the description, you will be ready enough to solve any problem related to this one. So if you liked the video, please subscribe and support us. Thank you.